Yeah, welcome to Unacademy YouTube classes. Good evening, all. Welcome to the session. Yes, you are welcome to VV Live. And if you are not yet subscribed for Unacademy Plus, you please use this code VV Live. So many benefits are there, right? Like premium content at affordable price, structured live courses plus dedicated live doubt clearing sessions, quizzes at regular intervals of self-analysis, batches for complete preparation, test series for DPPs, daily practice papers, full length mocks, etc. with detailed analysis. All of these are you're going to get under single subscription for unlimited access, right? Under this single plus subscription. So for that, you can use for this code VV Live. So here you can see that 20 plus top educators are there, 10 plus batches, 250 plus courses, 2000 plus lessons, and many more. Right? So students, if you are aspirant of EAMCET, okay, if you are aspirant of EAMCET and if you want good materials and good presentations in subjects, use this code and get the subscription from Unacademy, right? Unacademy Plus. Fine. Here today now we are going to discuss motion in a plane. Okay. Second class we are going to discuss, and yesterday we have seen few things related to motion in a plane, like projectile motion. As we have discussed projectile motion like a particle motion about a plane in between two axes, x and y axis. Likewise. So now here we are going to continue from there. And if you are asking me actually what we did yesterday in yesterday's class, once I will remind you that we have seen projectile path as parabola. Projectile path as parabola we have seen, right? And we have seen different parameters like maximum height, time of flight, range of a projectile, right? We have seen for all of those. Now we are going to continue from there, and now I can say that from yesterday's topic we are going to continue. See students, here this is one axis, say y axis, right? So let me take with another color. So this is of y axis and of this of x axis. So here one object is thrown from point of projection. Say from here it is thrown like this. So that time what happens, this particle moves and follows this path. As already told, these are the two axes. In between these x and y axis, this particle is moving with initial velocity u. It is projected at an angle of projection theta here, right? Now in that case we derived that range of a projectile. Range is nothing but horizontal distance, students, from this point of projection to the point where it is landing on the ground during its trajectory. Right here, this maximite point we can call this as A. This point is called as a B. So for this range, what we got yesterday, u square sine 2 theta by g we got, and also we have seen that maximum range as u square by g, where through sine 2 theta is 1. So theta is equals to 45 degrees. For that case, it happens. And now this range that is u square sine 2 theta by g is not only with an angle of theta, with another angle also the same range r is possible, right? Under u is equals to constant condition. For that condition, okay, let us move. Now you see, here is the, right, here one more diagram I am taking, right? From this point of projection, first projectile is projected with with an angle of projection theta, and the second one is projected with an angle of projection 90 minus theta. This value, this angle is 90 minus theta, students. This is 90 minus theta. This is of 90 minus theta. Now whenever it is projected and it is also reaching to the same distance on the horizontal axis, means range is the same for these two projectiles. What is the condition? Initial velocity of the two projectiles must be the same. So now let us discuss for that condition. Now you see here, range for the first projectile, I am calling it as R1. It is given as u square sine 2 theta by g. Whereas for the second projectile range, I am calling it as R2. R2 is nothing but u square sine 2, that angle theta can be written as 90 minus theta for the case of second projectile. See for this yellow color projector is there now, for that divides by g as it is we are writing. Right. Now so therefore u square here sine of 2 of 90 minus theta can be written as 2 into 90 180 minus 2 theta whole divides by g can be written. So now this comes like this, u square sine of 180 minus 2 theta can be written as a sine 2 theta, students, sine 2 theta by g. So this R2 comes like this, R2 comes like R1 only. So from this what we are going to say is, here, if this angle is, right, one second, yeah, see here angle is whether theta or 90 minus theta. If u is equals to constant, r must be the same, r also constant. This is the inference. So the same two angles I can also call as complementary angles. Those are called complementary angles. Complementary angles. What are those? These 90 minus theta and theta. Not only these two, we can also write it as 45 plus theta and also 45 minus theta. These are also called as complementary angles only. Now you see, for example, one projectile is projected here. So one projectile is projected with an angle of 30 degrees. So like this it is falling. Another projectile is projected with a 60 degrees angle. This is of 60 degrees, for example. So this also falls at the same point. Say this point as B. So two projectiles are going to fall at the same point, since these two are complementary angles, right? So likewise these complementary angles we can discuss in case of a range. And now see students, here we are discussing about projectile, and a few things again I can discuss here only. Suppose projectile is projected, one projectile I am considering now with initial velocity u. At the point of projection it is projected by making an angle theta, which is also called as angle of projection. Now students, when this projectile is projected, it is reaching to the maximum height and is falling on the ground. Usually we are calling this point as A, this point as B, right? Now in this case, what are the change in velocities? What are the change in velocities? For that thing we are going to discuss change in velocities. So for the total time of flight, if you are asking the change in velocity, okay, so time of flight means from here to here, time taken is said to be time of flight. So time for which projectile remains in air during its journey is said to be time of flight. Generally it is denoted by letter capital T, students, right? Now for that what I can say about horizontal direction, right? About horizontal direction velocity change and vertical direction velocity changes I will calculate first. About horizontal direction, what are the what is the change in velocity about horizontal direction for this case? If you see here, at this point velocity will be in this direction, right? In this direction its components can be observed. So in this direction, since this angle is theta, in this direction u cos theta takes place. So in this direction u sin theta takes place with a negative sign. Okay, it is downward now, so minus u sin theta. Here at this point of projection in this direction, u cos theta, since theta is making with a horizontal, in this direction u sin theta will takes place. U sin theta will takes place, right? Now you see here, change in velocity about horizontal direction. If you are asking me, this final velocity at this point about horizontal direction, and initial velocity about horizontal direction at this point we are going to take. So in that case, what I can say is this u cos theta, right? Okay, this u cos theta and this horizontal velocity, the change in velocity, u cos theta and this u cos theta minus u cos theta gets cancelled, so it gives 0. Right? Anywhere you see about horizontal direction, there is no force, external force, there is no change in velocity, there is no acceleration, we know that. And coming to vertical direction, what happens? You see, vertical direction. In case of vertical direction, here in this direction u sin theta is acting minus with a minus sign, so minus u sin theta, right? Minus initial velocity is in this direction u sin theta is acting. No? You have to see the components, this vertically downward component, upward component here. So minus u sin theta we are writing, and here, right, here plus u sin theta we are writing. So therefore plus of minus minus, final minus initial. Final one is minus u sin theta, minus sign, right? Initial velocity about vertical direction is u sin theta. So altogether minus 2u sin theta. If you are asking vectorial, I can say about vertical direction, it's a j cap, na? So I can put even j cap also. So I can say that here it is 2u sin theta minus j cap. Here magnitude is change in velocity. Okay, change in velocity magnitude is 2u sin theta. In which direction it is acting? About minus j direction, means vertically downwards it is acting, right? Likewise, here change in velocity for the total time of flight we can calculate. And now suppose between these 2 points, maximum height point and initial point. Okay, let us discuss about this. Right? Suppose you see here, this is y-axis, this is x-axis, right? This x-axis, right? Here like this it is projected, like this. If a projectile path is assumed, here is the maximum point, say this point as A, this point as O. Usually these letters we can write in this way. Now this is the maximum height point, friends. This A is 9. So change in velocity between this point of projection to the maximum height. So now here at the maximum, what is the velocity? Basically this is u cos theta about horizontal. There is no vertical component of velocity at the maximum height point, we know that. So here what are the velocity components? U cos theta about x direction, in this direction. In this direction what we have? In this direction u sin theta at the point of projection, students. At the point of projection. Now change in velocity means this about horizontal direction, u cos theta gets cancelled, minus, right? And final velocity means change in velocity about vertical direction, this 0 minus u sin theta. So therefore what I can say is change in velocity is nothing but this 0 minus u sin theta. Of course j cap is about y direction. So what I can say is u sin theta minus j cap. Like previous, we got like this, means this is the magnitude, which means change in velocity magnitude is u sin theta, right? And minus j cap is the unit vector about a negative y direction, likewise, right? And suppose students, if they are asking for momentum, change in momentum like that, if they are asking, what you are going to do? Basically, momentum is nothing but, we know that mass times velocity, mass into velocity. Already you know that change in velocity, no? So velocity term, you know, just you should multiply with mass. So change in momentum. Okay, for that what I am getting is magnitude of change in change in momentum is mu sin theta. Magnitude. Suppose change in momentum, if I want to write, change in momentum is nothing but, okay, what should I write? Here what we have, change in velocity, u sin theta minus j cap. Likewise, mu sin theta minus j cap. Hope you got for this step also. So change in velocities and a change in momentas during the projectile motion, we have to calculate in this way, right? So now in between these 2 points also you can calculate, like maximum height 2. See here, this is the maximum height point, this is the ground point, final point of the projectile journey. Even at that point also, okay, between those points also we can calculate for change in velocities and moment. Okay, hope you understood for this. It's a very simple but very important. And students, be remember, while subscribing for Unacademy Plus, okay, use for this code VV Live. Okay, you're going to get many benefits as students. Here, benefits, how it is given, you see, premium content at affordable price, reasonable price, you are going to get content. The structured live classes, not random concept. Okay, one topic if you are choosing, in that how many subtopics are there, and for each subtopic how to present the concept, and what kind of problems we have to discuss. All those, by looking all those structured live classes will be conducted through this Unacademy Plus. Be remember. And also dedicated live doubt clearing sessions. Usually students in physics, doubt clearing sessions, coming to the doubt clearing sessions, it is the big task even for teachers and lecturers also. So from this Unacademy you are going to get best team. So from the best team you are going to get this doubt clearing sessions, and usually regularly we are going to conduct for quizzes. So from that quizzes, what is the benefit? You can analyze yourself, how far you are comfortable with the subject, with that concept, right? And from that you are going to get one confidence in final examinations, competitive examinations like EAMCET, TS EAMCET or AP EAMCET. Confidence matters in competitive examinations, students. That only matters. Be remember, practice and confidence, these are very important. And for we are offering, means Unacademy is offering batches, n number of batches for complete preparation of the subject. You take any subject, maths, physics, chemistry, biology, and XYZ subjects. For all of those subjects, you are going to get complete preparation. Not like for 1 or 2, 3 chapters, right? And DPPs, you see here, daily practice papers. Daily you can practice from those valuable questions, right? Full length mock test will be given, and you can analyze yourself for that. Okay, use this code VV Live. 100% you are going to justify if you are a plus subscriber. Okay, I am sure students, you can go for this code. Okay, you can go for opting this code called VV Live, right? And now here you see, suppose here is one example. We are going to discuss for an example. See here. Here the situation is given like this. Here initially particle is projected, means this projectile is projected with initial velocity u at an angle theta, students. And now it is moving in its path and is falling at point B as usual, right? And this point is O, this point is A. Now, at what velocity, final velocity of a projectile is perpendicular to the initial velocity of the projection. Okay, once again I'm reminding for this. At what velocity final velocity will be perpendicular to? Final velocity means, you see, here is the initial velocity u. This u is given at this point straight. So like this it is moving. So here it cannot be perpendicular. Even at this point also it cannot be perpendicular. So this is the direction of projectile at the point of projection. Right? Now due to the gravitational force, what is happening? It is going to pull down. It is going to pull down. So likewise this path is deviating. Instead of this straight line path, it is taking into parabolic path as shown here. Isn't it? In that case, what we have to do is, at what velocity, at what velocity this final velocity will be perpendicular. Perpendicular means like this it should be, no? So what I am saying is, this is the meeting point. Okay, for visualization it may not seem exactly, but you have to take this as a meeting point of these two. So here it is the perpendicular. Sorry. So this is the velocity. So in that case, what I can say, I can resolve this vector. Okay, I can resolve this vector into its rectangular components, orthogonal components, that is 2 components, right? Here this will be theta. So this becomes u cos theta, v cos theta. This becomes v sin theta, students. Fine. Now, what I can say is, generally here what we have, u cos theta, no? At the point of projection. In this direction u sin theta we have. Very simple thing, students, you can observe. This u cos theta, generally this u cos theta remains same throughout the motion. That point we know. We remember. Throughout the motion means, even at this point, 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 or even at this point, horizontal component, that is u cos theta, remains the same. We know that. So from this information, students, what I can say is, I can equate both of those. Means v sin theta is equals to u cos theta. V sin theta is equals to u cos theta. From that, what I can say is v is equals to, right? He is asking for v. So v is equals to what? U cot theta. U cot theta. So that is the velocity at which both velocity vectors are perpendicular. Both velocity vectors means what? This initial velocity vector and this velocity vector. Both are perpendicular. Hope you understood for this, students. That very simple thing. Very simple. There is no much confusion in this. Simply what you are doing, horizontal component, you are equating with the final velocity component at that point, and therefore you are going to get it. And next, here we are going to discuss for horizontal projectile now. Horizontal projectile, students. It is another kind of projectile. Horizontal projectile. What is this projectile? We will see. Here in the name only we can see that it is projecting horizontally. It is projecting horizontally. Means from certain height. Students, you see here, from certain height, right, one projectile is projected like this. With initial velocity u, horizontally. So that time what happens, so due to the pull of the earth, which means gravity, right, like this, its path is changing, right? See here. Like this. As we know, this is x direction, right? This is the foot here. So from foot some horizontal distance also it is taking. For that also we will see. First you see this path. This is nothing but parabolic path. From the observations we can say that this is the parabolic path, and mathematically we have to prove for this. So mathematically how to proceed? See, students, about x direction. X direction distance is x, I can say. So that x is equals to, about this direction, X is equals to velocity into time. Velocity how much? Basically it is having horizontal velocity. Horizontal velocity how much? U only na, U into T. Let it be like this. So from this T is equals to X by U. T is equals to X by U I can write. Say this as equation number 1. And secondly, vertical distance. For vertical distance, if you are asking, what I can say, S is equals to ut plus half it square is there, no? S is equals to ut plus half it square. Let me write for that here, one second. S is equals to ut plus half it square is there. Second equation of motion. Sy, for vertical direction we are writing. Sy is equals to uy into t plus half ay into t square. Sy means what? This total distance, height of the tower I can say this as a tower or building. So height if it is given as h, for example, otherwise y only, let it be y first, y only. So y is equals to uy. At this point, velocity in this direction is 0. Uy is equals to 0, students, because it is having velocity in this direction only. There is no vertical component of velocity at the point of projection. For this case, be remember, in this direction uy is equals to 0. So let it be 0. 0 into anything? 0. 0 plus half. Okay, plus half. Ay means g. From the tower it is, from the height, certain height it is coming. So ay is equals to plus g. T square. So t square. So half dt square can be written. So therefore what I can say is half g. T is nothing but what? From the first what can we write? X by u whole square. Isn't it? So therefore y is equals to, okay, g by 2u square, okay, this into x square. So students, here you see this total is a constant, so we can write it as a, this g by 2u square can be written as a, x square as it is we are writing, and this represents a parabola. This represents a parabola. So from that we can conclude that this path of a projectile, this is also projectile. Path of a projectile is a parabola. It is a parabola. Sorry, like this. And what is the range? Range is velocity into time. Time from this we can get it now. 2h by, if y is equals to h. What I can write for this time? Right? See here. What we have? Y is equals to half gt square. We got now. So from this what I am writing? Y is nothing but height of the tower. If I write h is equals to half g. Okay. T is nothing but total time. Like that if I take. Okay. Total time is nothing but time of descent here from maximum to ground. T square. So from this t is equals to 2h by g under root. So if you are asking for range means what? This horizontal distance, this total distance. Already we are shown here with this. So distance is nothing but what? Horizontal distance. Range is nothing but horizontal velocity into total time. Horizontal velocity is u. Total time is what? 2h by g. So range comes like r is equals to u into 2h by g. So likewise, range depends on this initial velocity and the height. This is one very important conclusion and useful to solve problems in this case of horizontal projectile. Right? So likewise, these derivations we can get in this case of horizontal projectiles. Students, hope you understood for all of this. Basically, projectile is nothing but particle or body which is thrown other than 0 degrees or 90 degrees from the horizontal. And different kinds of projectiles we have, like oblique projectile. This is the case of oblique projectile. Oblique means making some angle. Here you see this is making some angle with the horizontal. This is the case of horizontal projectile. This is the case of oblique projectile. Coming to the horizontal projectile, what we have here? Horizontally it should be projected, but not from the ground level. It should be taken certain position. It should take certain position. Then only path can be taken as a parabola. Suppose At the ground level, if it is projected horizontally, what happens? It becomes one-dimensional motion, isn't it? One-dimensional motion. So likewise, students, we are getting for all of this. Hope you are understood for this. Thank you for listening, and I request you all to get more benefits. You please join and please subscribe plus subscriber Unacademy Plus. Use code VVLive. Use code VVLive to get more and more benefits. Right? Thank you all.